Hi. One of the important aspects as physicians that we're expected to know, or if you're a medical student or you plan to join medicine, is having a basic knowledge of biostatistics. So, I'm not an expert on the topic, and I just intend to cover a few important points, mainly focusing on definition. So, you're familiar and you can read more about these topics and understand better. So, biostatistics is nothing but the application of statistics to the field of biology, and in this case, it will be medicine and research in medicine and public health as well. And statistics covers planning, design, and execution of a study, processing the data analysis once a study is done, presentation and publication of the information, interpretation as well, and publication. Biostatistics is very important because unless we show that there is statistical support for whatever we observe or plan and execute a study, it's difficult to practice evidence-based medicine. Of course, not everything we do is fully evidence-based, and not all research evidence supports the practice that we do. And in some situations, there is defects like error creeping in or inadequate planning of the study, power is not adequate to meet requirements of a study, and so on. So there are many fallacies as well, but we need biostatistics to give authenticity, to remove a subjectiveness in any hypothesis. So we need biostatistics for designing a study in a methodologically study manner, to do sample size and power calculations so that we know how many patients we need to recruit into a study to get a particular result of significance. We need selection of samples without bias, so we need a process like randomization and differentiation with control. So depending on what kind of study we are doing, we need some support in terms of designing a questionnaire. So open-ended questions, not to ask leading questions, and to get evidence that will support your management. So it's very important to involve experienced people when you plan a study. And data management. So collecting patient information has issues with confidentiality, storage of information, who will see the information, sharing, permission to share, and so on. So again, it's very important that we have some training in data management, and we need to know what descriptive statistics to choose to use and represent our findings in graphs or other methods which will be easily understood by the audience. And application of univariate and multivariate statistical analysis techniques need to be understood as well. So just a quick overview of the types of data. So we have primary data, where the data is directly collected by the person studying the information, and it can be secondary data where we take it from another source where they've already collected the information for any reason. For example, public health collects data like census, which has lots of useful information which we can use for other studies that we do. And we have qualitative data which can be nominal or classificatory scale. So things which don't have a specific number will be gender, like you have male, female, you have exam results as pass or fail, blood group, you have certain groups, either you fall in that or you don't fall in that. So you have a nominal or classificatory scale, and ordinal or ranking scale, where you have more allotment sequence. So you can have a response to treatment which is poor, fair, good, and severity of disease, mild, moderate, severe, income status, low, middle, and high. And quantitative can be discrete, where you have a specific number of family members, number of admissions in a day, or it can be a continuous variable like height, weight, blood pressure, serum cholesterol, and BMI. So we have qualitative data, again nominal or ordinal. We have quantitative data which can be discrete, it falls as a specific number, or it goes as a range, as in height, weight, etc., which fluctuates in the same patient. It may vary from time to time. And quantitative data can be ordered based on intervals or ratios. So univariate data are where we look at one particular data, for example, weight of students. Bivariate is where you have two variables, like you collect height and weight. And the population is the group, the entire group that's being studied. A sample is a specific portion of the population which you are extracting according to certain characteristics which are predefined. So you define the population, then you define the sample and how you will select the sample. A variable is a characteristics that takes on different values in different people. So height, weight, blood pressure, these are all variables. And an observation is a particular event, recording or measurement. For example, if you are taking a particular reading of blood pressure, it's that observation. So you do collect a lot of observations in any study related to clinical medicine. And the data reflects a set of recorded values. The vital statistics is usually an ongoing collection by government agencies, usually mandated by law, of important statistics which include the birth rate. So the birth notification feeds into the birth rate, death rate, which is by death notification. These are mandatory and you have regulated time frames within which you have to do these. We have perinatal, neonatal, infant and child mortality, maternal mortality. So these have definitions which I'm not going into go into details, but I would refer that you review and be familiar. Mostly the community medicine textbooks would give you all the information you need. And we also need to have an idea of incidence of the public health disorders, including diabetes and vaccine preventable diseases. So when we talk of a distribution, which is how a particular problem is in the population, we can describe it in many ways. So we have a measure of central tendency. We can use the mean, median or mode. We will discuss that. And in terms of modes of dispersion, we have range, variance, which is mean deviation. We have the standard deviation and we have coefficient of variation. So these are all modes of dispersion of a particular distribution. So once you know how the tendency is, you can also look at the standard deviation, for example, to know how much variable it is. So variance is a statistical average of the dispersion of scores in a distribution. Variance is not often used on its own, but it can be useful on the way to a more descriptive statistical measurement like standard deviation. Interquartile range is a difference between the score delineating the 75th and the 25th percentile, or the third and the first quartiles respectively. So when we describe, it's useful to include tools of variation as well. So in general terms, mean is the arithmetic average. So if you have 100 distributions, a 50th distribution, if you add everything and divide it by 100, then you get the mean. Median is the middle figure and mode is the most frequently recurring figure. So these are all different tendencies, and according to situation, you may prefer to use one of them according to the size of the sample, the nature of the sample, and so on. Standard deviation is a measure which describes how much the individual measurements differ on average from the mean. It expresses in quantitative terms a scatter of the data around the mean, and it's the most important measure of dispersion around the mean, and it forms a basis of most statistical analysis. So when you're interpreting study results, you'd always have the range expressed as standard deviation. And it helps to describe the normal curve, so how big or how wide the normal curve is, how much of a skew is there, and it gives an idea of whether the observed differences in individual value from the mean is by chance or it is significant. So the standard error is also calculated from the standard deviation, and once you know what the standard deviation is in the population, it can help you assess for the sample size as well. So these factors lead to the normal distribution, which is also called the Gaussian distribution, and it's a theoretical or mathematical model to describe many biological characteristics. We described variables: height, weight, blood pressure, hemoglobin, cholesterol, etc. So these are all distributed by a Gaussian distribution within the population. So it was devised by Gauss from Germany and Laplace in France. Graphic presentation of the frequency distribution. It's symmetrical about its mean. It's a smooth bell-shaped curve. The distribution provides a foundation to central limit theorem, and you can also express by mean standard deviation as well. So normally mean plus 1 standard deviation would include 68% of the observations, and mean plus or minus 2 standard deviation would include 95% of the observations. plus or minus 3 would include 99.7%. So most of the time we use statistical significance if it falls within out with the mean plus or minus 2 standard deviation. So this is how the normal distribution looks like, and you have the 1 standard deviation on both sides which covers 68%, the 2 standard deviations on both sides which include 95%, the 3, and anything beyond the 3 third percentile on both sides is going to be outliers. Sometimes you get skewed distributions where one portion may be leaning. So we have the mean, which is the central value, and again it's representing what we mean by 1 standard deviation, 2 and 3 standard deviations about the mean. A skew is where there are scores towards one end of the distribution than the other, and when the scores of a distribution are more clustered at the high end, then relatively fewer number of scores on the low end, it results in a tail, and this is a negative skew. A positive skew is where a distribution shows a tail at the high end. In general, in a negatively skewed distribution, we expect the mean to be less than the median. So if it is negatively skewed, you have more positive, so the mean would be lesser than the median, and in a positively skewed distribution, we expect the mean to be greater than the median.